Hello, everyone. Welcome to week 2 of IR 421, in which we are going to continue from where we left off last week. And last week we were here. We learned how to create numerical vectors, string vectors, Boolean vectors. We learned how to combine them into creating data frames. We learn how to modify parts of the data frame, how to access rows and columns specifically. And we're going to continue this week from essentially where we left off. So last nice trick that we did was to create a new object called total GDP, which is basically here, which was a multiplication of population and GDP per capita. Now, let's continue exactly from where we left off. You don't even have to change anything or do anything. No. Now, let's add a new column to this because making these kinds of manipulations, adding column, changing column name, multiplying between columns, accessing a specific row, is really bread and butter of data science. As long as you can find your way in any CSV file, any comma separated values file, learning the rest of the options are mainly about how to learning how a new package does things. But as long as you're comfortable with these data manipulation, data tidying operations, you will always be good in data science. So now let's add a new column. Let's add a new column called continent. Let's add what these countries, which continent these countries belong to. And we will do this by using countries data frame that we have been working on. And we will basically do this, countries data frame in order to access an existing column or create a new column. We use the dollar sign. So immediately when we type the dollar sign, it gives us a menu of columns or options that are there. So in order to create a new one, we should basically write a new column name that doesn't really exist there. And in this sense, it's going to be continent. So continent, look at these columns: country names, population, GDP per capita, is OECD member, total GDP. Continent is not here. So continent, now we are going to be doing new. Continent is going to be our new column name. And this is going to be another string vector. String vector, as you know, means text of special names. And in this context, I need so Germany belongs to Europe, Brazil belongs to South America, China belongs to continent Asia, Australia, Oceania is the actual country name that spans all Southern Pacific nations. Oceania, Kenya is part of Africa. So we are going to basically say that in our list of countries: Germany, Brazil, China, Australia. Germany is Europe, Brazil is South America, China is Asia, Australia is Oceania, Kenya is Africa. And so remember, whenever we are writing non-executable command text, we have to wrap them with quotation marks. So Europe becomes wrapped around quotation marks, separated by a comma, another quotation mark for South America. Now, as long as I have something wrapped around in quotation marks, which means that it's a specific name, I can use a space. Whereas if I'm creating an object, if I'm creating a variable, if I'm executing a command, I shouldn't be using a space. But as long as I'm entering a special name, I can use, as long as it's wrapped in quotation marks, I can use spaces. Comma, China is Asia. Um, uh, Australia is Oceania or Oceania. I don't know. If this is a YouTube video, if anyone from Australia or New Zealand watches this video, please let me know how to pronounce that. But we know how to write. So what this is going to do is that it is going to, because this is a vector, the sequencing is important. So first value, second value, third value. It can't be random. So this is going to be assigned to Germany. This is going to be assigned to Brazil. This is going to be assigned to China, Australia, and Kenya as a new column called continent in our country's data frame object. So I can either run by selecting all, or I can run by coming at the end of this sentence and clicking run. So when I clicked run, notice that our 5 observation and 5 variable countries data frame became 5 observation and 6 variable data frame. And when I click on this, you're going to notice that the continent column is now added with the correct sequencing of continent assignments. Germany, Europe, Brazil, South America, China, Asia, Australia, Oceania, Kenya to Africa. We can add, we can do other stuff. The more you do these like data manipulation stuff, I think the more comfortable you're going to feel in these issues. So let's add a new column that ranks GDP per capita. We can, of course, do it manually by clicking on the sort arrow on the GDP per capita, but just for the sake of showing you what's possible, countries in data frame, creating a new GDP underscore rank. This doesn't exist, so we are creating it anew. A new object in which we are going to rank, which is a command. So there's a command called rank. When I add minus, it basically orders something from the biggest towards the smallest. So in this sense, if I say rank from smallest to largest in countries data frame, the column called GDP per capita, let's pause, I don't want to go too fast. This basically takes GDP per capita column and then ranks it from highest to lowest, and then adds this as a new column in countries data frame, so highest to small. So when I run this, this country's data frame object is going to have 7 variables now. So let's go ahead and do that. And now when I go, it is going to rank these from smallest. So the smallest, which is basically 1, is basically a GDP rank of 1. When we rank these, Australia, Germany, yeah, sorry. I just wanted to make sure that the data is accurate before I proceed further, but actually the data is accurate and this ranking is also accurate. Basically, this is a ranking of GDP per capita, GDP rank, and because it assigns first, second, third, fourth, and fifth based on the criteria that we offered it, which is basically rank GDP per capita, Australia per capita is the richest country. I needed to check. It is actually richer than Germany in that regard. The second is Germany. The third is China. Fourth is Brazil. So everything is actually accurate. I just wanted to make sure that everything is accurate. So when we rank GDP per capita, it basically ranks them from highest to smallest and adds a new column called GDP rank into our data frame, basically. So essentially, these operations are quite important as you modify parts of data frames. Now, in Excel, we would also change individual cells by just clicking on them. So if we had to, for example, update Germany's population, in Excel, we would just like double click or single click and then like type stuff. Now, in R, nor in Python, we can actually do this because R and Python, both programming languages, you may find them less user-friendly compared to Excel, in which you can just like click on stuff. But in being less user-friendly, they're also less error-prone, meaning that they don't allow you to make mistakes. Now, with Excel, user-friendliness comes in with a higher risk of making mistakes because you're clicking on stuff, you're adding inputs manually. R doesn't really allow you to do that, nor does Python. So in order to change things, for example, let's say Germany's population is no longer 83, but let's assume it's 84. Now, if we had to change Germany's population in our list, we can't really click on this. So we can go all the way back here and change the population vector, revise our numbers here. But the bigger data set you have, the more difficult it starts to become. And because right now I only have 5 values, it's easy to change. I can just go and say 84 here instead of 83. But imagine a data set which is like thousands of rows, thousands of columns. It is impossible to find it in a vector that goes into infinity. So you need to be specific about updating a specific value on a data frame. So that in that sense would be something like, once again, what are we trying to change? We're trying to change a data frame. So we need to name that data frame. In our context, it is country's data frame. And what are we trying to change? I'm trying to change Germany's population. So I need to change the population column here. So that would basically be on country's data frame column population. But we can either do second row, second column change, the stuff that we did earlier here, like referring to a cell by its row name, row number, and column number. But for the sake of showing new things to you, change population in such a way that I change Germany's population back, but I can't really put Germany here and change Germany's population. What I need to do, the correct, data science correct way of doing this, you may find this, I don't know, a little bit like time consuming, but remember, like most of you, this is just your like second lecture on data science. So when you become better at this, it's actually not going to be that time consuming. You're just going to like type this without any chance of making a mistake. So you basically do this once again using the country's data frame function, and you need to specify country names in that regard. And we are going to be using this double equal sign. So single equal sign in R is usually reserved for mathematical equations or statistical formula. In order to separate single equal sign from the data science lexicon or syntax, in which you have to exactly match a specific value. In this context, it has to be Germany. We use double equal signs. Now, it takes a while to understand the difference between a single equal sign and a double equal sign. And confusion is normal in that context because even though I find our language tidier, easy to manage, like I overall think it's calmer, tidier language compared to Python, which is very powerful, but it's like super chaotic as you go further along the way. But R is sometimes not very straightforward, to be honest with you. And I'm not invested either in R or Python. I just use whatever programming language does the best of what I intend to do. And even though I love our language, sometimes it's very not straightforward or not very user friendly. So in order to be able to just like go here, change this value for Germany, I need to specify a column, I need to specify Germany, and then I need to be able to say that for this context, change its value to 84. I understand that some of you may find this uneconomical, which is like way too much stuff to do to change just one single value. And my Excel students from IR 202 would be able to say things like, "Oh, I'll just go here, double click on it, and then change." Yes, I mean, but if we are to do less mistakes, which we do a lot with Excel, this is how it works in R. You specify the data frame, you specify which column needs to change, then in the column, again, which country, which row number, and specifically which actual value needs to change into what. So in this context, look, now we have 83 with all this verbose coding. I'm going to click run and go here back again. Now it has changed Germany's population to 84, which in a way, you might really be quite, you might rebel against this, but at the end of the day, in order to understand these things, the more options you see, I think the better it's going to be. We can also add a new column called GDP, so not GPT, GDP to population, which is going to be the ratio of GDP per capita to population. That will look like countries data frame, and new GDP to population ratio, for example. And this is basically going to be, once again, countries data frame. It is going to take GDP per capita, and then it is going to divide that with, once again, countries data frame. Let me make this bigger. I'm trying to get you more comfortable with using this dollar sign and specific, referring to specific parts of the data frame in population. And this is going to basically, doing this option is going to create a new column, once again here, once we do the operation, which is going to be GDP per capita divided by population. And so we do run. Once again, we go here. So this basically divides GDP per capita by population, essentially, which gives you a different mathematical operation function, essentially. Now, let's go a little bit more. Let's extract countries from here that are just OECD members. And in this context, it's going to be Germany and Australia. Let's create a new, what is this? Let's create a new object for OECD members. And here it's going to be OECD underscore members or OECD countries. From countries data frame, how are we going to pull from this country's data frame? We have to once again specify, we have to unfortunately write this several times, we have to pull is OECD member, because whether a country is OECD member, whether that value is true or false, we have that data in the is OECD member section. And only take countries from here, which again, we are referring to this as double equal sign, because this is not a mathematical formula or a statistical equation. This is just, we have to get that, we have to get that precise number, in which we have to get true for countries. We add a comma and then nothing, because the true values are row-based and not column-based. That is why we are leaving the column designator empty. It is true, comma, and nothing. Remember, when we use brackets, when you separate by column, the first part of the column, what lies towards the left of the column, denotes rows, and what lies after the column are they denote columns. So when we do this, when we run this code and look at here once again, there's going to be a third data frame is going to be here. OECD countries, 2 countries with 8 variables, and in which case it extracted only countries whose value for is OECD member is true, and it just left false ones outside. So we only have population data, GDP per capita data, continent data, GDP or whatever, only for countries that have that are OECD members. And at any given time, you can always type OECD countries here, because now it makes sense. Like there's value attached to that object. You can always run the object to output the values of it in the console terminal below as well. Oh, what else? GDP per capita. Let's play with GDP per capita. Let's sort them. So let's take rich countries. Rich, how do we define rich? Rich so that their GDP per capita is above $10,000. So we would create a new object with China, Germany, or Australia, but not as calling them Australia, Germany, and China, but by calling them as countries whose GDP per capita are greater than 10,000 US dollars. So this would be filter countries as rich, such as those with a GDP per capita greater than 10,000 US dollars. And that would be then sent to another object, a box of values in which we hold those countries. Let's call them high GDP countries, in which we have from countries data frame. We are going to extract GDP per capita for all countries. So that would be countries data frame. Once again, within this, we also have to call the data frame as it is, which is going to be, once again, the dollar sign. We have to GDP rank, GDP per capita. But the condition for this is that it has to be greater than $10,000. But this is a conditional for rows. Remember, every single time we have these brackets, not like the curvy parentheses, but like the brackets, we always have to define what is our criteria to work with rows and what is the criteria by which we work with columns. If we have a criteria for rows, we have to specify. And in this context, we have no criteria to work with columns. So again, this is a comma. The first part of this comma designates what is your operating principle for row-based operations. And the second part is for column-based operations. Now, in this context, I only need to take all of these country values row-based as long as their GDP per capita is $10,000 and above. So I'm going to take everything row by row, and I don't have any other commands for the column, which is why there's space, there's emptiness after the column. We don't have any commands for the column. That's why it's empty in a way. If we had specific instructions for column-based selection rationales as well, we would populate this second part of this column as well. But we don't have any criteria, which is why we basically write the column and then do nothing. Now, once I run this code as well, we are going to get a new object here, a new variable called high GDP countries, in which only countries that have a GDP per capita above 10,000 numerical value that I assign to it. So I'm going to run this, and now I have a new object called high GDP countries. And when I click on it, it has Germany, China, and Australia, relatively wealthy countries whose GDP per capita is above 10,000 US dollars. What else can we do? We can sort by population in descending order. So, for example, sort countries by their population in a descending order. These operations are very critical because as we progress further and work with more complex data sets, I don't expect you to memorize these things because, there are like thousands of commands in R. But the more you work with these, you start to get a sense, a feel of our syntax, basically how R speaks and what language R understands our intentions and wishes. The more you use these in different combinations, the more comfortable you're going to get with learning new packages, working with new data sets that you're not very familiar with. And it's generally about 90% of our work in data science is basically getting data, cleaning data, sorting data, ordering data, adding criteria, taking a group of values, extracting it into someplace else, creating objects. So this is really the very most important fundamentals, if you will, of data science. So, for example, in this context, where I say sorted by population, this is a new object in which I'm going to get, again, countries data frame, in which I'm going to use order, which is an ordering permutation, returns a permutation which arranges its first argument into ascending or descending order, breaking ties by further arguments. Shortlist does the same. So it basically does order really from highest ranking to lowest ranking, but it needs to contain a value. And I can't just go and say population because it needs to be referred to using country's data frame $sign population. And because I'm in brackets and I'm trying to refer and call a row-based sorting order, because all of these population, sorry, let's close this, let's close this. All of these population values have to be linked to the countries they're assigned to. That's why I need to do a row-based operation. Again, the column-based part is empty. I don't have any order that goes into column. I just need to take the entire row-based criteria and then assign them to a new object. So I am selecting this and clicking on run, and you're going to see that we now have sorted by population thing as well, in which now this is automatically sorted from lowest to highest. Highest China, then Brazil, then Germany, then Kenya, then Australia. So it basically takes population as a sorting criteria and then takes all of those countries as a sorted version of this, and then it basically displays the same. Now, you can always say that I can get the country's data frame and I can already do these operations here. Like, I don't need a sorting operation for this. Yes, but what if you cannot do a visualization with country's data frame because you need it for another operation? So you need a specific object in which you can visualize, but you cannot touch the country's data frame operation. These operations evidently, over the course of time, become quite useful. And yes, you can technically do this, but sometimes the data becomes so complex and so large that you have to take that ordering principle and take it into a different object so that you can continue working with this object further along the way. I think we have created quite a lot of new data. So, I mean, just to remind ourselves of summary statistics, we can always do summary statistics, use the summary function, countries data frame, population, right? So you can always run this and it's going to give you population, minimum population, first quartile population, median population, mean population, and then third quartile and maximum population as well. I mean, this is mostly like a data science class. I'm not going to go that much into the specific of statistics. But if any one of you had difficulty understanding what summary statistics is, didn't take my IR202 course on Excel, don't know how to interpret and do descriptive statistics, summary statistics, email me. I'm like happy to help in any way I can, because this course doesn't have a prerequisite, specifically because some of the best performing students in this class sometimes came from like really zero background, but worked so hard that they eventually ended up getting like really high grades for this course. So that's why I don't really designate prerequisites. But if you haven't taken any Intro to Statistics class, those of you who didn't take my 202 class, email me. I'm happy to help in any way you need. The same thing goes for summary statistics. You can go use data frame, GDP per capita. It's going to give you the minimum observed country, first quartile, median observed, mean observed, third quartile, and maximum observed country. And so we can actually group by continent and calculate average GDP per capita. So we can do, for example, things like average GDP per capita by continent. Let's using T apply or apply. I'm going to show you what T apply is. Good and nice data wrangling or data manipulation tools. Let's create a new object called average GDP per continent. There we get T apply. So T apply a function over a ragged array, apply a function to each cell of an array that is to each non-empty group values of data rows given by a unique combination of the levels of factors. You're going to understand now, once we actually use tapply, by getting our country's data frame. From this, take GDP per capita, and then comma, country's data frame, this continent, and then we add the mean value. So what is this going to do? Let's run and then talk about what this does. So I am running this. It gave me average GDP per continent, and let's print this average GDP per continent to see what it has. So if we had multiple countries in this list, it would be giving us the mean values of each continent. But here, maybe this wasn't a very good example, but we basically have one country from each continent. So if we had multiple countries, like if we had France, if we had Nigeria, if we had New Zealand, if we had Argentina, or for example, Mongolia here with multiple countries, it would basically create the mean of those countries, and then it would give us the average result of this. Now, what else can we do? Let's try average GDP, which is different than my previous command. Before we do this, actually, let me show you how to install packages as well. Now, in data science, in R, in Python, how do we do a map? How do we do network analysis? How do we do text mining? How do we do advanced statistical analysis? How do we do mathematical advanced functions? Like any kind of how do I do this question in R and on Python as well? The answer is usually there's a package for that. What is a package? A package is a combination of pre-written commands, which without that you would be able to write them in base R, but somebody came up with a helpful idea to combine certain commands and certain command combinations into what we call packages, which basically makes your life easier. So how do we do packages? I purposefully went into the beginning of this session because uh, the more you learn about data science, the more packages you end up using for projects. The more you learn, the more you become better at this, the more complex your projects become, and the more you do, the more packages you end up requiring. It is always a good practice for a data scientist to list the packages that they're using at the beginning of a session, simply because of the fact that as you introduce packages further along the way in like line 34, line 76, it's very easy to get lost and forget which packages were loaded in this session. Of course, you can always go to the packages section and look at, which ones are used, which ones aren't used. But especially if you're installing a new package, from downloading a new package, listing them explicitly in the beginning becomes a good practice. So first, we install a package from the Comprehensive R Archive Network, or CRAN. So we download packages from the Comprehensive R Archive Network. Remember, last week we downloaded Base R, not RStudio, the interface, but R, the brain, which you don't see right now, which is like in the background. We downloaded this from the Comprehensive R Archive Network, or CRAN. Most R packages, the best known R packages, are also in CRAN. There are some in GitHub. We have in this class people who don't know what GitHub is. I'm going to show you how to use GitHub as well. Right now, there's no point in like confusing you further. We download packages from CRAN using the syntax install .packages. Now, sometimes beginners make the mistake of confusing these two: installed packages, and sometimes they say installed packages and then try to download a package and say, oh, professor, I can't download this. Yes, because you wrote installed packages instead of installed packages. Installed packages shows you which packages are already installed. Installed packages actually goes to CRAN and install package. I'm sorry about the confusing vocabulary, but bear with me. Now, we are going to download arguably the most useful package from CRAN. And let's go and say tidyverse. I want to first explain what you're downloading because it's very important. So tidyverse is a collection of R packages designed for data science. All packages share an underlying design philosophy, grammar, and data structures. So data plier. So these tools like pliers, data pliers, so the data manipulators. One thing you should know about R packages is that they're named in very funny ways, and usually it is not very straightforward or newcomer friendly, those package names. So my students are always like, what is lubritate? Like, what is per? What is ggplot2? And I mean, people who are naming these things, guys, like, I don't know how many of you are watching this video. This is like a free lecture on YouTube and whatever, but how am I going to explain this to my students? What is ggplot? Like, ggplot is, of course, grammar of graphics plot, the second version. Yes, but I mean, it still doesn't make sense. Dplier. Plier is a tool that allows you to just like move and like um, manipulate some objects. So data plier is a plier for data. Yes, I understand, but how is this meaningful, guys? Really, like tidyr, the commands that make our tidying data in R easy. But how is this meaningful, or how is this useful to newcomers? Like, yes, this is like as further along the way, I automatically know what the dplyr does, what ggplot does, what stringr does. Yes, as so many people, but like this is really not student friendly, and such as Lubridate. But whatever, people who are taking 4-1 computational social science, we have a package called tidyverse, and it is a package of packages, or a mega package, or a giga package, which contains every single smaller package for which you would use data cleaning, data tidying, data manipulation, data importing for R. This is not something that is going to become clearer the more I talk. It is going to become clearer the more I do. And the more you do, you're going to be, more familiar with these things. But, these package names, they often don't really make sense. So you basically install complete tidyverse with install packages tidyverse. So let's copy this. So install .packages tidyverse. How are we going to use this in our studio? So I already wrote half of the code, but we come here, basically do paste, install packages tidyverse. You can either run as this, or you go at the end of the line and click run, install tidyverse. And then it is downloading the tidyverse commands and sub packages from the comprehensive R archive network. So now it is still continuing. One thing again for newcomers to programming. If you're seeing this smaller than sign, which is this smaller than sign, if you're not seeing this, it means that R is working on something else. It's either processing, or it got stuck, or doing another operation. Best thing, if you're not seeing this, don't do anything. Wait for R to complete its operations. If you're seeing this and the blinking cursor, then everything is fine. So it has downloaded a bunch of other packages from R, and we download packages from R. We usually download a package only once, because you're taking it from the internet, CRAN, taking it to your computer. But after each time we create a new project, we have to identify packages to the library of the project that you're working on. So we install only once, but every single time we're going to use tidyverse from now onwards, we have to take it from the library. So once you just write library, it is automatically going to give you a list of all the packages that are already installed in your computer. You may be seeing different lists here because this computer, I've been running R for quite a while. I've downloaded tons of packages here. You may be seeing less packages here. That's perfectly normal. No need to panic. But here we are going to, and if it's a package, it is like apparently explicitly listed as the letter P. P, so here I need to do the tidyverse. So we need library tidyverse. In the installed packages section, we need quotation marks because in this instance, R doesn't know what a tidyverse is. So you need to specify, use the installed packages function, go to go to comprehensive R archive network, find this package called tidyverse, and then install it. But now that it has installed it, you no longer need to use double quotations. You can just run library tidyverse, and it is now brought the library tidyverse from the library to this specific session. So in this specific session, I download the tidyverse because I'm going to show you the sign dollar bigger than dollar. So what is this? So, sorry, not dollar. It's percentage sign, greater than sign, and percentage sign. This sign is the pipe operator. Pipe operators link command chunks to each other. Think of pipe operator as a chain. Each time you use the chain, you link code chunks to each other. And in this context, I'm going to get country's data frame, use the pipe operator, and then I'm going to type enter. Now, remember, last week I told you that we can write codes in chunks as paragraphs, if you will. So this object is going to be created through data frame, pipe operator. After the pipe operator, if I hit enter, look, it basically brings the cursor indented towards the right-hand side, which means that this is now a continuation of the codes above. So I can say group by continent, and then use the chain function or pipe operator function. Notice once again, because it's chained, it's linked, it continues here. Summarize average, sorry, average GDP, which has to be the mean of GDP per capita. Yes. So what does this do? Let's run average GDP here. So if I had multiple countries in this list, it would create a different object called average of continent GDPs because we are just like working with a small data set of just 5 countries. It is basically taking the only value for that continent from the only country data from that continent, which is specific country average GDPs. But if we had more countries, for example, next week, we're going to download an actual world development index database in which we're going to have 180 plus countries, all of the countries in the world, and we will be doing operations with them. So there will be multiple countries for Africa, multiple countries for Asia, multiple countries for Europe, and Oceania and South America as well. And that is when these kinds of things are going to be important. What else? Let's work with missing values. Sometimes when you download a dataset, you are going to face with empty values, empty cells, not available values, or missing values. And it is important to talk about missing values annually. I think it's important to know how to go about handling those missing values. Those of you who took my IR 202, we had different ways of dealing with not available values. In world development indicators, remember, you would have these like two dots in place of missing values. So in Excel, in IR 202, we would go and change all of those two dots values to NA values, or not available values, and then we would just like remove them. Now here, for the sake of exercise, from countries, data frame, and within GDP per capita, let's assume that data frame. Let's assume that country names. There are more economical ways of writing this code. The more advanced you start to become in code writing, there are different syntaxes, there are different lexicons of writing this code. Right now, what I'm doing is that I'm like reaching with my right hand and trying to pull my left ear in order to make it more clear to you how our syntax works. So that's why everything is like long and clear and explicit. But as we progress further, we're going to transition to less verbose, more efficient types of code writing. But for now, what I want is Kenya. Yeah. And I want GDP per capita for Kenya to be a not available value, meaning I don't. What is Kenya's GDP per capita? Kenya's GDP per capita is $2,000. So this is going to appear as not available once I do this. I do run. I go to countries data frame, and now look, Kenya's GDP is not available. I purposefully edited Kenya's existing GDP as a not available value because I'm going to show you how to identify a missing value. So we identify missing values like NA or N/A, or sometimes this is NA, and sometimes like two dots, as we see in world development indicators, whatever. So we identify missing values through this R command called is not available. So when you say is not available, just like the Excel's find function, because remember, when we use Excel, we used find and replace. When we wrote find, we wrote find not available values, or find two dots values. So here we say is not available. If something is not available, do an operation with it. So here, what I'm going to do is that I'm going to create a new object called missing GDP object, which is going to contain all not available values, ISNA, from country's data frame and from GDP per capita. So if there are any missing values, take them into this missing GDP section. So now I have a missing GDP section in which it's a logical operator, which is going to check which GDP per capita value in my country's data frame is not available. So Germany does have GDP per capita. Brazil does have GDP per. So this is true, false, 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 true. Kenya has a not available value. And here, in the missing GDP object that I created, a logical operator, false, 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 true. That true is the Kenya GDP per capita. So what we can do, for example, is we can replace missing GDP per capita with the mean, excluding the not availables as well. So country's data frame would then take something like GDP per capita. But from this, I need to tap into missing GDP. And this needs to contain the mean of country's data frame. In country's data frame, dollar GDP per capita. And we have to remove not available values. So what is NA.RM? Just like ISNA, maybe it's better to, we are definitely missing values with ISNA, replace missing values with GDP with the mean. Maybe I should write here that NA, which means not available, RN means remove, not available, remove. So we are basically removing any not available values. So it takes true or false designations. So when we are going to run this, we are going to country's data frame. So it is automatically doing a mean of GDP per capita and automatically assigning it to GDP per capita missing values. So basically, you identify missing values with ISNA, and then you remove not available values with NARM true. And then if you have any statistical principle through which you can replace those missing values, you basically apply a statistical concept or principle. In this context, it was mean. And so then it would replace all of those not available values with the statistical average or a statistical principle that you would basically have. Finally, let's work a little bit with conditionals. If else. Okay, so let's do country's data frame. Let's add a new column called income category, whether that country is rich or not. And from there, we are going to say if else returns a value with the same shape as test, which is filled with elements selected from yes or no, depending on. So you're going to understand what this means now. So if in my country's data frame, my GDP per capita designation is above the numeric value of 40,000, then assign a value to the income category which says high income. Then if else, another parenthesis, country's data frame, GDP per capita, if this is above 10,000 US dollars, which is like somewhere below 40,000, but above 10,000, then render them middle income. And maybe the biggest trick in that regard is that if we have a country that is above 40,000 GDP per capita, call them high income. If they are above 10,000 but below 40,000, call them middle income. And everything else, which is countries that are not above 40,000 threshold and countries that are not in between 10,000 and 40,000 threshold, call them low income. Now, this might be a little bit confusing, but basically we are asserting a criteria in which, if else, countries above 40,000 is high income, above 10,000 and below 4,000 middle income, and everything that exists below that as low income. And this is going to be a new column, a new category in the country's data frame, which is going to automatically assign high income, middle income, low income based on GDP per capita of that country. So we select these all. And now I'm going to go to my country's data frame, country names, population, GDP per capita, is OECD member, total GDP, their continent, their GDP rank, GDP to population ratio, and our new friend here, which is the income category. High income, low income, middle income. So let's sort them. Which are our high income countries? Germany and Australia, because they're above 40,000 GDP per capita threshold. Our only low income country is in this regard Brazil, which basically in terms of GDP per capita is in a way lowest, and then China and Kenya are defined in this context as middle income countries. I'm pretty sure it did a calculation error somewhere. I can't really find it, but I'm pretty sure that Kenya is not a middle income country, or Brazil a low income country. But in the case of working with data, this is basically how conditionals work. So in Excel, we would always import a CSV file and then work with it on Excel. Now, if I want to save this as a CSV file, how do I do it? How do I export this data frame? So in this context, saving a data frame as a CSV, which is comma separated values file. Now, we do this using the command write.csv. So you're going to notice both in read CSV and write CSV commands, we have write.csv, write.csv2, write underscore CSV, and write underscore CSV2 files. I'm going to explain to you what these are in the coming weeks. Basically, they use different package sources in order to do those operations. For now, do write.csv. Now, we write .csv. What are we writing as CSV? we have to write this as a CSV file. So the object name that I need to convert into CSV is called countries data frame. I have to convert that. But then that's not enough. I have to specify the file name. What should be the actual file name? You can say my R exercise underscore data frame dot CSV. And when doing this CSV, especially if I'm going to take the CSV to Excel or Stata or Python or somewhere else, I need to get rid of these numbers. So these are row names. It automatically assigns a row number to each of these countries based on the ordering by which I have added them into the vector back when we were doing these string vectors. We have to delete this. I don't want 1, 2, 3, 4, 5 to appear. Because when you import this to a different software or a different programming language, this is going to get you into trouble. So what we do is that row names, the logical value of row names, false. We don't need the row names to go into my R exercise data frame thingy. So if I run this, it is going to create a new file called my RxSite. And so what I can do here very easily is that I can go to my search and I can say my R exercise. So just by writing the first few letters of this, I have my exercise as data frame, and then you can go and open this up, for example, in Excel or any other programming language that you are using. But this is basically our tiny little CSV file, which we created on Excel. Those of you who took my IR 202 course will be able to do this text to column thingy and then converting them into actual Excel files. We have numerical errors here, but that's not really the point. Don't say. You might say, for example, which folder or directory am I working in? Get working directory command. If you run this command get working directory, it is going to give you the output of which directory you're working. So in users folder, I have an Akın Ünver folder, and Learning R Studio, remember, is the name of the session that we basically did. And so that is how you get the working directory. You will know where this is being set. But if you want to change your working directory so that R saves your stuff into a place that you actually would want, you would basically do set working directory, and you would basically need to set an actual folder into which you want all of your R saves or R files or environment to be in. This is basically here. You're going to notice that your CSV is here, project is here. This is home Learning R Studio, but you can always do things like downloads, do R exercise, then do things like week 2, and it's oh no, cannot change. Oh, it's because I mean in my computer this trajectory is entirely different. But I'm going to show you in the next weeks how to set a working directory for the specific computer that you are working in. For now, basically, this is how you set a working directory. How do you save this entire session? Is that you go to File, you basically do Save All, and it basically asks you, how do you want to save this? And you can basically go to Documents. You can do it in Downloads, anywhere you want. I would suggest, for example, going to a document, open up a new folder, for example, called IR421, which is going to be the folder in which all of your IR421 work is going to be at. You can do IR421, week 2, 3, but basically you can save this session this way. There's also a disk save all open documents, a save all option, which basically saves everything to that file, basically. But yeah, so that is a fast track entry into R. Of course, when you are working with R or with a programming language first time around, watch as many different tutorials as possible. Learn from as many people as you can. There are tons and tons of good YouTube tutorials around online, and I'm going to share some of those in the LMS, which you will be able to access. And just like you are following and typing, my lectures, you'll be able to follow those lectures as well. And again, back when I was learning this, we didn't have that many resources anywhere. So you would have to just go read a book of methods, which would 100% always be used, like very difficult. But nowadays we have like a wealth of information, wealth of videos, incredible instructors, professors, teachers online. Definitely benefit from them, and I'll be able to on YouTube. Those of you who are not taking my class, but like watching this on YouTube, I will post some of those like very good tutorials here as well, so that you can um, coordinate your learning through my videos with the learning you have from those videos. So thank you so much for joining me. I hope this basically gave you some idea on how R works. R is an incredible language. It's very tidy, very clean. It's very powerful. I love it. Doesn't mean that I don't love Python. I love Python as well. It's as if like you say, I love Python, you automatically people expect you to hate R, or when you love R, people automatically expect you to hate Python or anything. Don't do that. Learn all languages. All languages are good. Use the one that is going to be more straightforward with the kind of project that you're working on. But thank you so much for joining me. And I'd like to get your comments, get your questions about anything from this video and beyond. And see you in class. So thank you so much and take care.